All right, great. Welcome, good morning. Welcome to Thursday. I'm James. So Andy, Cullen, and I will be talking about other modalities and how one would annotate those in a language such as UMR and AMR. And the goal for me is to set the stage for Andy to talk about a specific extension to AMR, gesture AMR, which it falls within gesture UMR, which is attempting to integrate UMR into other representations, other modalities, and extend the scope and purview of the representation languages such as AMR broadly. Okay, so we'll talk about a little bit of the setup. So a couple of you might have seen this from last year. If you were here, we have some new material, and it's a broader scope for what we're trying to accomplish. So the goal of the one component of our large in scope and large, not as large as in resources, but still the NSF work that brings you here, funded by the National Science Foundation, is to increase the application of meaning representation languages, UMR, to languages other than the high resource languages. The signature example applied is Arapaho, and we're looking at other resource languages that have been presenting interesting problems to classic AMR, such as multi-word, expression tagging, and other types of light verb constructions, things like that, which have been instantiated in the extension to Chinese. Czech is another example showing morphosyntactic and morphologically rich and case-rich languages that need additional material. The other component under our charge for the grant or the research is to extend to the other modalities that are involved in communication. So we take, particularly Andy and I in the group, a kind of classic view of what is a communicative act between individuals, between humans. By extension, anything applied in computational circles to HCI, computers, or HRI, robotics. But we'll talk mainly about just human-human interactions, what is abbreviated as HHI. To that end, we think gesture is as important as the speech act. Look at me just how I'm doing kind of ampliative gesturing right now. Gaze, attention, co-attention between individuals when I'm gazing at someone. Joint attention to an object. You're jointly attending to the screen or to me, or maybe back and forth. So gaze and attention are critical. Action and the recognition of action through perception, or a sound through auditory perception, etc., and so on and so forth, are critical informational components to communication. So we'll generalize and not think about a sentence or a proposition, but we'll try to generalize to the notion of a communicative act. So, key to this, and one of the things that we're really moving towards, and what I think any linguist who's interested in the cognitive and social aspects of communication is mainly interested in some of the big issues. This idea of identifying a common ground and then maintaining it and trying to track what we think about each other. What do I believe about your intention? What do you think about my intention? So this is a notion of a shared conceptual space. I won't go into any formal details. That's not the role here. I just want to kind of frame why we're thinking about gesture in the way that we're thinking about it. We, as I mentioned, need 3 at least serious components. We'll look at gesture today. There's information associated with our environment that comes ready to use. Just the objects wear this information on their sleeves, as we say in English. That cup projects information that it's grabbable, it's liftable, it's drink-outable. And this is information that can be encoded as a semantic representation, some sort of XMR, I'll call it, or some type of knowledge graph. And we have this type of information. The key now, that before I move into the real presentation, is that we're embodied in our situational environment and our interaction. And you'll see that with my examples and with Andy's examples. So, we are embodied, meaning that I can't take the meaning of something to be just the expression that I've annotated, or just the speech signal, or just the visual signal. It's integrated. We do the integration by virtue of our wetware in our cortex. We need something similar in the computational algorithmic design of our architecture. So we have the shared belief, shared perception, co-attention, co-intention, and let's look at an example. I have a mom and her son. They're icing cupcakes. It's just a classic joint activity, which I'm going to have a real-world example of. And we have a dialogue for these. The dialogue is just filled. It's packed with deixis, co-reference, anaphora. But more than that, there's just the updating of the information from the actions is actually all being dynamically put into the current situation. So this notion of dialogue state tracking and common ground tracking is now something that's being formally computationally modeled. It's no longer just the provenance of philosophers. Some of the elements from the common ground are, as you might imagine, they have joint intentions. They see the same objects and things like that. So this is what the challenge is. Now, here's an example. I'm going to show a shared conceptual space. This is a task called Eggnog, where I have two people. They're in different rooms. They can see each other and they can hear each other in one case. And this person is gesturing to this person how to build a construction, how to build a particular configuration. We have multiple versions of this where you can only speak, you can only gesture, or you can use gesture and language. Let me give an example of how this works. You may not hear it terribly well, but let me just give an example. It's only like 50 seconds long. So this is the signaler, the director, and this is the actor, the builder. Okay?
So, starting from the top, moving to your left down the floor, diagonally a row with the corners touching. In the other direction, it's the same, except for there are 5. One less than that. Yeah. On the side with 4, on the last one, on the inside corner, there's another block. Yeah. It's just on the table. Like not stacked. And then down 1. Yeah, and touching corners. Same on the 4th block on the other side. Between the block you just placed and the 3rd block on that side is touching those 2 corners. And there's one touching that block's bottom corner. That's it.
Okay, now she was not particularly full of gestures. She was mainly language. And there's a variation. Now the thing about that scene that we'll talk about is the updating of the situation, my awareness of the situation, and then the availability of what kind of definite description or pronoun can be used in a kind of Gricean sort of maximally efficient way to uniquely identify what to do. So she's talking about the corner. Well, there's 4 corners to deal with, but in that situation, there's only one available corner. Okay, so this is really interesting, and it's not trivial to update the information and then have the available linguistic expressions, be they from a rule-based system or from an LLM, generate the appropriate linguistic phrase that actually correlates with the current situation. That's the problem of common ground tracking. Okay, so AMRs don't do this. They don't describe human gestures or interactions. So a woman drinks coffee, that's going to be the AMR version of woman drinks coffee. Here's a first order representation. Here's a kind of VerbNet representation of it. Okay, and this is the AMR representation. And the first thing to note is it's context unaware because it was never meant to have context associated with it. That was not the goal. The goal was actually to be generic, a predicative core, and you've gone through it, you've already heard all this. So, but behind all this is an incredible amount of what we call a dense paraphrasing of the situation. And some of that is, almost all of that is something that we use to understand a scene. In a discourse, we have all of these things I already mentioned, and in order to do that, we have to have a discourse structure, we need some sort of gesture, and we need some kind of interpretation of action. So let's just assume that a communicative act is going to be all these things, and we're going to focus on speech and gesture. There's also going to be gaze, facial expressions, and actions. Okay, now we can think of, before we get to the adoption of the specific typology in gesture AMR, within interaction for humans to do a joint task, we have pointing, we have iconic actions, and then there's something that we call affordance denoting gestures. Generates how to actually interact with an object. So I can go like this, right? So what can I do with that? I can do this. What can I do with that? I can lift it, right? So, but that's also kind of an iconic gesture. And then there's direct situated actions, which is I'm actually going to step or I'm actually going to lift, okay? So we built an entire virtual simulation in Unity for this just to kind of experiment with permutations of this. That's not relevant to our current presentation. But one thing that we'll note, I think Andy will talk about this too, is you have entire sequences of gestures, which is kind of a gesture narrative, but it's not really a narrative, it's actually a sentence. So I point to the purple block, I move like there, and then I point to the blue block. Okay, now what's interesting about this, I think I have an example of that. Yes. This is the generated form, but we also have the real form. This deixis, what am I asking the person to do? Yeah, what?
So you are pointing something over it, like it's, you will take this from here or something. You are pointing as actually giving a gesture.
Yep, I've got, I don't have any blocks, but yes. So I've got, sorry, I'm hobbling. I broke my toe the other day. So I'm pointing to that,
Yeah.
and then I gesture, or like this, which means move, put it onto this.
Oh.
Okay. Now, in the context of the task, how do I know it's on? Because basically I've said, okay, we're gonna build a structure. Okay. So the pretext, that's the precondition. That's my prior, right? So imagine that in the fairly constrained world of in-context learning and prompting. Okay, ChatGPT, we're going to build a structure. So that sets up the expectations for how am I going to interpret that next prompt.
It's like including core references.
Right. So what's interesting about this is an incredibly complicated thing to interpret semantically. The first deixis is referring to or denoting a block or the bowl. The second one is denoting a location. Yeah.
Location over.
And not just location, but a specific constrained location that is determined by the prior I've established for our joint activity, which is, where can I put it? Oh, well, I can't put it there. Right? I'm not going to do this. I'm going to put it on top. Okay? But that's not part of the semantics. That's part of what the pragmatics is telling you. So we have these various situations. Communicative act can be gesture, speech, or the combination aligned with them. Now, Kendon is kind of taken as the starting point for most people working on gesture, a really nicely written compilation that kind of takes together his own work as well as a lot of work of McNeil, and then two semanticists, Alex Laskridis and Matthew Stone, wrote a really nice formal interpretation of Kendon and McNeil in 2009. And essentially, we turned this into a grammar. So gesture can be an optional preparatory stage, kind of like, okay, I'm going to get ready. And then the pre-stroke hold, which is kind of, I'm going to do it. And then I'm going to go stroke, which is like the dices, and then retraction. Okay? So it's essentially just a little bitty finite state grammar. So the stroke is the content, that's the head of the phrase. Now, clear, kind of obvious semantics would be, take the denotation of a point, this is going to be ray trace or cone trace, the vector, take the terminus of this cone, and then from the actual vector, and then look at that, and I see a region. Now, if anybody knows general lexicon and knows the notion of the dot object, so I think this is the or dot object, where I point to something and it's a region, and if it's full, it's the object in the region. If it's empty, it's the location. Now, the thing about this interesting case that I mentioned, the pragmatics, that's not the case here. I have to actually kind of accommodate and say, oh, it's the location on top of the object. Okay, so for example, I say, let's say I have an empty table, I say, okay, what does that do? What am I doing? Just move this thing right to the location. It's just a region in 3D space, right? Okay? But if now I have this, say, then it has to be somehow accommodated to a kind of a configuration with that. So there's more information going on, right? By the way, interrupt at any time. So the original gesture grammar we had was really just straightforward little finite state grammar. I had a point, which had the direction, an object, an affordance was basically an action, like an act of movement with an object, kind of as its argument. And the grammar was basically this action-object grammar, which was like you grabbing an object. And so you have a gesture phrase could be, you could have an action focus, which would be the action first and then point, or you could do the object first and then the action. So you could focus depending on what you want. It's a little bit of free word order, and this would also be putting something at a specific location. But I'm not going to focus on that because we moved away from that to be more generic for a couple of reasons. One, we didn't have a finite domain of the vocabulary for the actions. So I wanted to basically leverage an existing language resource. What language resource would be the most appropriate? Well, there's a really nice one called PropBank, and there's one called VerbNet, which is associated with it, which in fact we've already enriched with generative lexicon sub-event structure. So why don't we go ahead and just use VerbNet for actions? So that's what we did. So starting with the notion of dependency trees, which you're familiar with, I've got head dependent and a label. So this is just a small arc within a label transition system in LTS, right? I have a root and I have a label, and basically the result is essentially just a triple. Triple, again, is a knowledge graph. Okay? It's a simple RDF triple. Later on, ask me why I keep focusing on knowledge graphs. So in gesture, I have a root, it's the agent. The stroke is the head, the referent, H is its referent, and the dependent is D. So an arc will form a rooted tree. Each arc has a label. And so for an example, I have a hand and a block and a deixis. So here's an example. My colleague Nikhil Krishnaswamy, and who co-developed this model with me. So he's a root. The head is his hand. The label is a deixis to the dependent. Okay? And that's just represented as a deixis. An action is him moving, okay, to that. To move that object. And here's another. So this is basically what I was taking before. That moved there. Okay, now, so let's put that together. So that essentially would be to move that object there. So here's another one, deixis. Now, this is what I call a constructural coercion, and Adele Goldberg I think also calls this a constructural coercion, where basically what's happening here? I want you to construe this. I've got two dices. What's going on? I have to construe what's going on, what's happening.
You and you.
So yeah, so that to there. What am I going to do between those things? I'm inferring that I'm going to put it. So I'm inferring, it's kind of coercion or an accommodation. I know I'm going to have to move the thing. Okay? So that's I'm construing or coercing it to be put. In a grammar, in a multimodal grammar, we have to link these in some sort of feature structure. Okay, now, this motivates gesture AMR. Is this okay? Is this too slow? Is this about right? So we wanted to exploit, and this is what I really was kind of excited to kind of discover when we were doing this in the context of multimodal communication. We wanted to exploit the dependency, the relationship between UD, or dependency structures, and DAGs, namely AMR. And this basically gave us a way of effectively utilizing a representation that's already been exploited for the speech, which of course would be the linguistic AMR, the gesture that we're going to turn into an AMR, and then conceivably for all the actions and even the gaze, we're going to turn everything into an AMR, everything, what we're calling XMR. But we're going to do it, of course, mutatis mutandi for UMR, but that's actually in a way for this true. Makes the alignment very simple. So here's the first step. So in gesture AMR, we need to represent the situated meaning, the common ground, the objects, but what we're going to focus on, and we're going to abstract away from the physical descriptions and just look at the structure of the gesture. You saw some of these guys. This is someone we call Graybeard. He was particularly good with, very rich with different types of gestures. So we studied this 8 hours of video. We annotated in Elan, which was the tool you saw, which I'm sure you're familiar with, and came up with a really, I think, very basic annotation schema that Andy has adapted to a completely different language and enriched with really nice additional features. So basically, gesture essentially is going to be modeled with how speakers move their hands. Most schemes focus on the hand shape and the movement, which is really important. I mean, you have to do that. But we're focusing on how it's tied to speech, okay? And so to that end, we're focusing on a lot of the work that is not what's done by Schlenker and much of the pragmatics and discourse community, which deals mostly with amplitude and things like beat and focus and things like that. We're dealing with what we call content-bearing gesture to a large extent. However, with the extension to Arapaho and what Andy's been doing, we have to get back into looking at ampliative interpretations, or what's called co-suppositional interpretation. So here's the basic schema. I've got a gesture act, and I'm taking the gesture to be the agent, and then this is the person I'm addressing, and this is basically the content. So it's like a speech act. It's a communicative act. So think of the family of communicative acts, and the communicative acts will be I knew that was going to happen. Well, that's a bad one too. Okay. Communicative acts. I'll have a speech act. There'll be a gesture act. And other things, such as there'll be face. So you tell me that you did not use GPT on your homework, and I go, what did I just express? It's pretty obvious, a little bit of doubt, right? So I'm communicating. And then, of course, there's gaze, right? And communication. What did you get at the grocery store? I pull out of my bag a large pineapple. I just communicated. I answered you. I acted to answer the question. So action has to be part of that too. So that's our little simple hierarchy. And that is here, but this is the content. That's where the action will be developed. So this is similar to dialogue AMR, but dialogue AMR was actually already kind of stealing from the ISO representation of ISO dialogue X. This is, which is Harry Bunt and me and other people from ISO. The initiator of the gesture is the person who's saying it or doing it. I'm talking to you. This can be an individual, it can be a group. And that's the semantic content. So deixis, we're focusing on the gesture, the addressee, and the content is literally denoting an individual, a block. This is iconic. This is an imperative. It's an imperative. I think in the context, Andy, correct me if I'm wrong, but for you, so the iconic can actually be a past event. That's preterite. It's actually deictically in the past. But here, this is an imperative. This is, you do this, okay? So, but the content, but generally just think of this as being potentially an event description. Slide to this direction. And then metaphoric is a very open class. So here we take a kind of sortal array of terms that are going to be just whatever we can use, and this is a little bit of an art. Do you have a specific number of these? Or how do you define the values for metaphorical types?
We actually have like a gesture-con.
Yeah.
That we try to keep track of all those.
Yeah.
Because you can expand very rapidly.
Yeah, right. So we've done it just on a need basis. And then emblematic, this will be an interesting thing to discuss. That's like thumbs up or thumbs down, something that is a conventional interpretation. In the context of this, an emblematic, this might be a way of getting attention from the teacher. We have that in some of our videos. But it can also be when somebody says, what step of the task are you on? You can say 1. So we have digit recognition. So in the first, that's emblematic. In the second, that would be iconic, referring to the digit. You can put them together to form, as I said before, these sequences. Okay, iconic, deictic, and so on and so forth. And then you can align them. So just before I hand things over to Andy, why is this important? Well, gesture, as with actions, contribute to the context. I already gave this example. I gave a similar example. I used this for the sketch. I lift a pencil. My brother said, right? And then this is a bridging relationship. So the relationship that we see here across modalities is something that we've been interested in. In fact, we're doing multimodal anaphoric annotation. Being one of my PhD students, we've been trying to look at bridging and accommodation, co-reference across modalities. So this is something that would, in the Poesio, for example, data set, be a classic bridge, okay? I've got, this is going to be a component or part of or sub-event from going to the store. Okay, and I will stop there and hand things over to Andy while we transition. Are there any questions? Yeah.
Is the initiator always agent?
The initiator is the agent, yes.
Yes. What if sometimes a noise or something triggers some signs or something?
Oh, you're thinking about other things that would contribute? Oh, absolutely. The auditory environment is absolutely as important. So we have this happen all the time. We'll be giving a lecture. I lecture in this room. And a fire alarm will go off or something like that. Everyone hears it if you're hearing enabled. And so it's clearly something that I don't have to mention, but I can't talk during it, so my behavior is impacted by this. And so it's in the common ground. I don't have to say, oh, there's a fire alarm going on. I'm not going to talk for 30 seconds. It's a given, right? That would be violating Gracie maxims up the wazoo. So we have to model that. Yeah.
What kind of application do you have in mind when we,
What kind of applications?
what kind of application do we have in mind when we are developing this kind of resource?
Well, we're doing HRI, human-robot interaction, but also for better human-human, just for the cognitive modeling, I find it fascinating, okay? As an application, there is no multimodal AI agent that can do any of this. None, okay? LLM-based systems have no data for other modalities besides language. You'll hear they do, all the new stuff coming from Meta and Google, but it's video that they've scraped and stolen from the web. It's not multi-party interaction, okay? That's actually real. And even if you're looking at the law, we can talk about this later, probably tomorrow when we talk about LLMs in the panel, but the training objective they use is completely off. It's not, it has nothing to do with binding the way the action or the referent or a person or a gaze is actually being talked about and then referenced state to state, okay? It's all trained for very specific benchmarked QA tasks, okay? But, so, okay.
Just one question. How do you combine these annotation, gesture annotation, with the annotation of the speech of the language? Do you, because we have, she's speaking.
So UMR is the way to go with this, because UMR gives you something that actually is very similar to what minimal recursion semantics has, which is basically an equation. We just do equational linking. So I say, oh, AMR would never allow this. AMR has multi-sentence linkage, but that's kludgy at best. This basically just gives an equation, you read it and say, oh, you're the same guy as that. Or and to that end, you can actually exploit if you have the full capabilities of the, let's say, the time-ML temporal relation. Say, this gesture is essentially happening within this speech time, okay, or overlapping. And you can actually train the models to say, that gesture happened so far before the speech, is it actually denoting the same thing? Or maybe they actually mean something different. And that's what we're working on now. That's an excellent question. Yeah.
Are all of those gesture annotations, especially grammar, are they all like context sensitive? It's because if we recall that when we are having a pointing, right, we will know that who is pointing and that's pointing and who it is pointing to. And for iconic, we will know that, oh, move, and who is saying that move this, and who is he gesturing to. The point is, like, we don't know what is a related object.
So, great question. This relates to any annotation task. Let me give you a comparison. So, it's completely contextually sensitive. And if you go to my book with AMR, machine learning annotation, or any of the best practices from time-ML, space, probably anything that Jan has done, you do in the you annotate in the context. So, for example, okay, first off, UMR does need sentence-based tense. Okay, it's lacking there. It'll change. Take something like, I am leaving. What is that? It's progressive present. Okay, I leave. John leaves. What is that? That's present tense. When is John leaving? John leaves tomorrow. Bingo. Textually, I now make an approximate future. I've got the information there. Okay, Chinese wouldn't even have the present tense, but English does. Take advantage of that present tense. There's a present tense interpretation in English which allows for an immediate future. So, the context says, you have to be future. I have to annotate this as future. And that's the context that's required for a language model of any sort. A language model which is statistically based or rule-based, probabilistic, whatever, or an LLM, to know that given the appropriate features and context, this is approximate future interpretation of the present tense. Same thing with gesture. The context tells me that's an object, not a location, given my prior context. Okay? And that's why another reason why LLMs are so bad at this. They don't have prior context. They fake it by having 48 attention heads, but if you have an LSTM, you can do it just right out of the box, for example.
So can I understand, like, that just leaves a space to allow the merging of other modalities and then absorbing other context information?
Not necessarily other modalities, and we have to get on to but to the information that's coming from the context, yes, yes. Okay. We'll open it up to discussion. question. I want to make sure Andy has enough time. Thanks.